Assalamu alaikum. Good afternoon, everyone. I hope you can hear me. Please give me a thumbs up just to confirm this. Okay, good. Okay, just a minute, please. A lot of people are coming in, so we'll wait for 1 minute more. Gee, I hope everyone is fine and had a lovely winter break. So, welcome back. In A1, we have two components, P1 and M1, pure mathematics 1 and mechanics 1. Before our December exam, we were doing P1, and our two topics of P1 are left, that is differentiation and integration. Now we have to start from the differentiation. In this week, inshallah, we'll cover differentiation, and in the next week, inshallah, we'll cover integration. So by 22nd of January, we have to complete, and inshallah, we'll complete that, our P1 syllabus. And after that, we will start our M1 syllabus, and we will complete that by the end of February, inshallah. So let's begin with the differentiation, which is a purely a new topic, the topic of calculus. Let's begin differentiation. The topic, these two are very important topic, differentiation and integration. That's a pure calculus basically. And almost 20 to 25 marks, almost 20 to 25 marks of P1 comprises of these two topics, differentiation and integration. So does anyone know, okay, what are we going to study in these topics in differentiation? Anyone, any idea about differentiation, that what we are going to study here in this topic in differentiation? G, derivatives. Yes, differentiation is derivative, you are right. So basically, if I go back to the O level, when you were doing the graphs of functions, I hope you remember the graphs of function. Suppose that we have this curve. Maybe the equation of this curve is y is equal to x square minus x plus 2. Suppose maybe that is the equation of this curve. So just recall your knowledge of O level, the graphs of function. If the question was to find the gradient, if the question is to find the gradient of the curve at x is equal to 3. Say this is 1, this is 2, this is 3. G, does anyone remember how you are finding the gradient at x is equal to 3? The method was that if you want to find the, yes, Zainab is right, that we have to draw the tangent. If you want to find the gradient at x is equal to 3, mean at this point, then we have to draw the tangent at this point like this. Then the gradient of tangent, we need to find the gradient of this tangent, and we know very well how to find the gradient of a straight line. We will take any 2 points on that straight line, maybe this one and this one. We use those 2 points in the gradient formula, which is y2 minus y1 over x2 minus x1. We That gives you the gradient of that tangent. So that gradient of tangent is basically the gradient of the curve at x is equal to 3. I hope everyone remembers that you were used to do this in your O level. So, but if you remember, the gradient by using graphs, by using tangent, was an approximate value. If Abdul Muiz was getting the gradient 3.1, maybe Fariha was getting 3.4, Tamur is getting 3.7, Isra is getting maybe 3.8, and Moaz maybe getting 3.2. So almost everyone was getting the different answer. Why? Because by using graph, that was the approximate gradient. Because the gradient, the tangent of everyone is not similar. It's there's a difference of tangent, and then when you are taking the values, there is some difference there as well. So at the end, you get different answer, but all of them were considered right. And that gradient was an approximate gradient. Now here, this topic, differentiation. Here, if you want to know what we are doing, please come on time. This is the first day, so I'm allowing you. Next time, you will not be allowed to enter in the class after 5 minutes. So when you come late in the class, you keep on asking the question what we did in the first minutes, what we are doing, what we were doing. So please don't avoid now these. So the gradient we found in O level, gradient of curve, by using the tangent. But this topic, differentiation, will give you the accurate gradient. Here we are going to study the topic differentiation. So what is the actual practical use of this one, differentiation of this topic, is that this, after studying this topic, differentiation, you can find the gradient of curve at any point accurately, exactly. If the gradient of a curve at any point is 3.1, so differentiation will help you to find the gradient exactly 3.1, where in O level you are finding only the approximate value of the gradient. So I hope you got what we are going to do here in this chapter. Here in this chapter, in differentiation, we will be finding the gradient of the curve at different points. And this differentiation will help you to find the gradient accurately at every point. Okay, now that was the basic introduction of this chapter, that what we are going to do in this topic. In this topic, we are going to find accurately the gradient of the curve at any point, any curve. But for this, you should be knowing the differentiation. You should know how to differentiate given curve. Suppose this is a curve y is equal to x square minus x plus 2. If this curve is given, you should know how to differentiate this curve. If you know the differentiation of the curve, then you can find the gradient of that curve at any point. Okay, it means if you want to find the gradient or if you want to differentiate, we need to learn first the techniques of differentiation. Now, let's do the first technique of differentiation. We have to study two techniques of differentiation, two rules of differentiation here in AS. Okay, let's study the first one. And before starting this one, I want to tell, okay, whenever a curve is given, suppose y is equal to this one, x square minus 3x plus 2. Suppose this is a curve. Our first job will be to differentiate. So this curve is written y in terms of x. So when it is written y in terms of x, always you will be differentiating your curve with respect to x, because here it is x. So you will be differentiating with respect to x. So what will I do? If I write d by dx, there are some notations I want to tell. What does this notation mean? If I write d by dx of any number, then this means that you are going to differentiate with respect to x. If I write d by dt of a certain expression, so what does it mean? You are going to differentiate with respect to t. If here is the expression in terms of x, like x squared plus 5x minus 3, definitely you will differentiate with respect to x. If here is the expression in terms of t, maybe t squared plus 3t plus 5, then you have to differentiate with respect to t. So it depends on the variable, that with respect to what variable you are going to differentiate. So usually our curves are written for y in terms of x. So all the curves are written y in terms of x. So we have to differentiate all the times with respect to x. So if you see here, okay, the above curve is y is equal to x squared minus 3x plus 2. Now what will we do? We will differentiate on both sides. We'll apply d by dx on both sides here, and then we'll apply d by dx on the other side. So if you apply d by dx on y, so this will be simply dy by dx. Now the whole chapter is based on this. That what will you get here on this side? If you differentiate this expression with respect to x, what will you get? So the whole topic is based on this particular step. Now we need to learn a rule for the differentiation. And what is that rule? So let me
Sorry,
write that
Sir
rule
Tayyab.
first.
Assalamu alaikum, Sir Tayyab. Before you
Alaikum
begin, can you please get everybody to switch on their cameras? This is by default now. It's been a year. Everybody at LGS knows what the SOP is. I don't know why still students have their cameras off. Nobody should be in this class with their cameras off. Abdullah Qureshi, if you don't switch it on, I will remove you from the class. And Sir Tayyab, after 5-10 minutes into the class, if you see somebody's cameras off, please remove them. I will not tolerate this now. After a year of constant reiteration of these SOPs, they should have their cameras on now. Please. Thank you, sir.
Right.
Thank you, sir.
Okay. If you see here, the first rule of differentiation I'm going to write, that if you want to differentiate, when I say d by dx, it means I'm going to differentiate, and I'm going to differentiate here x raised to power n. That's a general. So x raised to power n, the rule of differentiation, Mikhail, please stay focused. So if you differentiate here this, the rule is that the power n will become coefficient, base mean x as it is, and subtract 1 from the power n minus 1. That is the rule of the differentiation, the first rule of differentiation. And what is that? If you want to differentiate x raised to power n, it will become nx raised to power n minus 1. Now what does it mean? Examples. If we have to differentiate, suppose the question is to differentiate x cube. If we have to differentiate this x cube, so differentiate mean we have to apply d by dx. D by dx mean we have to apply d by dx on x cube. We want to differentiate x cube. So apply that rule. The power will become coefficient, mean power 3 will become coefficient 3, and subtract 1 from the power, so it will become 3x square. So you have differentiated x cube and you got 3x square. G. So our first job here will be to know the techniques of differentiation, that how to differentiate a given expression. Once you learned all these techniques, then we will apply practically this on different shapes, on different curves, that how will you use this differentiation to find the gradient. But our first job is to learn the techniques of differentiation. Okay, now second part, see some more examples. If the question is to yet you have to differentiate x5 plus x3 plus x4 g. Now we have to differentiate x5, x cube, x4 separately because all are being added. So first we'll differentiate with respect to x5, then we'll differentiate x cube, then we'll differentiate x4. Okay, if we differentiate x5, we will get 5x4 as per that rule. 5 will become coefficient and subtract 1 from the part. So 5x4 plus, if we differentiate x cube, 3 will become the coefficient and subtract 1 from the part, 3x squared. And if you differentiate x4, so 4x cube. Once you have differentiated, in that step, no need to write d by dx. Here in this step, you have differentiated, so no need to write d by dx again. So this d by dx shows that you are going to differentiate all of them. Okay, now more examples. If I say differentiate x square x cube minus x square plus x plus 1. Okay, now let's differentiate one by one. Abdullah Qureshi, the screen has been shared, so if you can't see, then you need to rejoin. I think there is some problem on your side then. Okay, if you want to differentiate x cube minus x squared plus x1, so let's differentiate one by one all of them. So here the differentiation of x cube is 3x squared minus the differentiation of x squared is 2 will become the coefficient, and if you subtract 1 from the power, so it will become 2x power 1. Simply the differentiation of x squared is 2x. Now what's the differentiation of x? The differentiation of x, g. If I differentiate x here separately here, so it has a power 1. So if I bring the power 1 here in the coefficient and subtract 1 from 1, so 1 minus 1, so it will be 1, x raised to power 0. So x raised to power 0 is 1, so answer is 1. So it means the differentiation of x is 1. Plus, what's the differentiation of 1? What's the differentiation of constant? Yes, 0. Differentiation of constant is 0. No need to write this. And why it is 0? Let me tell you why it is 0 here. If it is written 1, so there is no term of x with that. But so if you can say that there is x, but its power is 0. X raised to power 0 is again 1. So it is same as if you write 1 or simply x raised to power 0, it's the same thing. So if you differentiate x raised to power 0, 0 will become coefficient. And then 0 minus 1 is minus 1. So when you multiply 0 with anything, you'll get 0. So just remember that the differentiation of 1 is 0, or you can say the differentiation of a constant number is always 0. If you want to differentiate 3, it is 0. If you want to differentiate 8, it is 0. So differentiation of a constant number is always 0. Okay, more examples. If you want to differentiate x8 minus x6 plus, yes, Rotab, you will be seeing that all the examples will be repeated. Here in this example, you will see I'm repeating that same thing. Okay, what's the differentiation of x8? 8 will become coefficient, power 7, x6, 6 will become coefficient power 5. What's the differentiation of x? The differentiation of x is 1 minus, what's the differentiation of 1? The differentiation of 1. I told you that the differentiation of 1 or any constant is 0. So this will be 0. So no need to write this one. More examples. If we have to differentiate x10 plus 7, x10 plus 7. So differentiation of x10 is 10 x raised to power 9 plus 7. 7 is a constant. And we know the differentiation of a constant is 0. So 10x raised to power 9 plus 0. No need to write that 0. So simply it is 10x9. Okay, more example. If we have d by dx of 3x raised to power 4 or 5. Now, what if there is a coefficient already existing here, like here, there's already coefficient 3. Listen, you don't have to differentiate coefficient. You don't have to differentiate coefficient. When you have x5 and its coefficient is 3, this coefficient 3 will be written as it is. You don't have to differentiate this coefficient. I know this 3 is a constant. There's a difference between when you are differentiating. Both the 3 are constants, but this 3 is purely a constant and this 3 is usually called the coefficient. When you are dealing with the coefficients, you don't have to differentiate coefficients. But if it is a constant only, 3, the derivative of 3 is a 0. But derivative, you don't have to differentiate constant. Like here, if you see this example, if you want to differentiate 3x raised to power 5, 3 will stay as it is. Only you will differentiate x5. So if you differentiate x5, you will get 5 coefficient x raised to power 4. Or you can write, now these two coefficients will get multiplication and you'll get 15x4. And you can write this directly. See, I haven't differentiated 3 here. So remember, you don't have to differentiate coefficients. Okay, see another example. D by dx of 8x cubed minus 7x squared plus 5x plus 3. Okay, now if we differentiate, remember this 8, this minus 7, this 5, these all are coefficients. So we don't have to differentiate them. 8 minus 7, 5 will stay as it is. But this 3, this is purely a constant. You have to differentiate this. And we know the differentiation of a constant is 0. So differentiation of 3 will be 0. But for the others, I'm going to differentiate. The differentiation of 8x cube is 8 will stay as it is. That cube will become in the coefficient and that will get multiplication with 8. So directly you can write 8 times 3 is 24x square. And 7 with 2 will be 14x. What's the differentiation of 5x? We know the differentiation of x is 1. So what will be the 5x? The differentiation of x is 1. So 5 times 1 is 5. So the differentiation of 5x is only 5. And the differentiation of 3 is 0, which I'm not writing here. Quickly, another example, d by dx of 5x raised to power minus 7. This is now minus 7. Whether it's negative 7, positive 7, fraction, positive fraction, negative fraction, rule will stay same. The power will become coefficient. So minus 7 will become the coefficient, and already there's a coefficient 5. So minus 7 into 5, that will become minus 35. And subtract 1 from the power. So minus 7 minus 1 is minus 8. So we got minus 35x raised to power minus 8. Now we want to differentiate this. 3x raised to power minus 5 plus 2x raised to power 1 by 2 minus 3x plus 11. Rule stays same. Whether the power is, okay, I'm going to the previous page. Here it is. Ismail is asking for that. Okay, here 3x raised to power minus 5 plus 2x raised to power 1 by 2 minus 3x plus 11. Let's differentiate this now. So 3 into minus 5, that will become minus 15. Minus 5 minus 1 is minus 6. Okay, now see, the next one is 2x raised to power 1 by 2. Now the power is fraction, doesn't matter. The rule will stay same. Now that 1 by 2, I'm doing 2x raised to power 1 by 2 separately here. If I have to differentiate this, see, I'll write this 2 as it is. The coefficient will stay as it is. If I have to differentiate x raised to power 1 by 2, 1 by 2 will become coefficient. And I need to subtract 1 by 1 from the 1 by 2. 1 by 2 minus 1. What is 1 by 2 minus 1? It's minus 1 by 2. So overall, this 2 and this 2 will be cancelled out. So you'll get x raised to power minus 1 by 2. So the differentiation of 2x raised to power 1 by 2 is x raised to power minus 1 by 2. What's the differentiation of minus 3x? The differentiation of x is 1. So minus 3x is minus 3. And for plus 11, it's 0, which is constant. The differentiation of pure constant is always 0. But the constant, which is a coefficient, we don't have to differentiate that. Okay, now we have to differentiate 1 by x4. Yes, who wants to tell how to differentiate this now? Any idea? Yes, Abdul Muiz is saying that bring x raised to power 4 in the numerator. Yes, so I'm not going to differentiate in this step. I'll write d by dx as it is. I'm just preparing myself to differentiate this. And how will I do that? I'll bring x4 into the numerator. It will become x raised to power minus 4. So always bring your variable, mean x, into the numerator whenever you are going to differentiate. So d by dx of x raised to power minus 4 is now quite easy for you. Minus 4 in the coefficient. Minus 4 minus 1 is minus 5. So that's your differentiation. And if you want to write your answer positive, because original question was having a positive coefficient, so we can write minus 4 over x5. Next, if you want to differentiate 1 over under root x. So what we have to do, we know that under root x is basically, I'm not going to differentiate in this step. I will simply write x1 by 2. We know that under root mean x power 1 by 2. So if I shift x power 1 by 2 into the numerator, it will become x raised. I'm not differentiating in this step. I'll write x raised to power minus 1 by 2. So first bring this x raised to power 1 by 2 into the numerator. I got x raised to power minus 1 by 2. Now I'm going to differentiate. So minus 1 by 2 will become coefficient. X power, subtract 1 from minus 1 by 2. So minus 1 by 2 minus 1 is minus 3 by 2. So, or you can write like this, minus 1 over 2. You can bring back x raised to power minus 3 by 2 into the denominator. So it will become x power 3 by 2. So I hope you got this. Okay, next is if you have to differentiate now this 5 into cube root of x. This is 5 times cube root of x plus 3 over x minus 5 by 11. Okay, let's differentiate this. I'm not going to differentiate this in the first step. I want to prepare myself for the differentiation. How will I do that? I'll write cube root of x as x power 1 by 3. And I'll bring this x into the numerator. It will become 3x raised to power minus 1. And this minus 5 by 11 is a constant, so it will stay as it is. So I haven't differentiated in this step. I just wrote the cube root x power 1 by 3, and I shifted 1 over x into the numerator. I got x raised to power minus 1. Now I'm going to differentiate this. So if I differentiate this, 5 is a coefficient, will stay as it is. That 1 by 3 will become in the coefficient. So 5 into 1 by 3 is 5 by 3. Now subtract 1 from 1 by 3. So 1 by 3 minus 1 is minus 2 by 3. Minus 2 by 3. And if we differentiate this, minus 1 will become coefficient. So already there is a 3. So 3 into minus 1 is minus 3. X raised to power minus 1 is minus 2. And what's the differentiation of minus 5 by 11? Minus 5 by 11 is a constant. So its differentiation will be 0. No need to write. So our final answer, we can write, we can convert, we can shift this into the denominator to make the powers positive. So this will be 2 by 3, and this can be written as 3 over x square. Okay, here is a question for you now. You have to differentiate on your notebooks under root x plus 2 over under root x. Differentiate this. Find the derivative of under root x plus 2 over under root x, or simply differentiate under root x plus 2 over under root x. You have to differentiate under root x plus 2 over under root x. So the first step, you don't have to differentiate this directly. First write under root x as x raised to power 1 by 2, and the other x raised to power 1 by 2, and that shift that into the numerator as well. Don't differentiate in the first step. Simply you can write this x raised to power 1 by 2 plus 2 x raised to power minus 1 by 2. I haven't differentiated in this step. Now you can differentiate this into the next step. Now you are ready to differentiate. So you will get 1 by 2 as a coefficient, and if you subtract 1 from 1 by 2, you'll get minus 1 by 2. And if you multiply the power minus 1 by 2 with 2, you will get minus 1 only, because 2 and 1 by 2 will be cancelled out, and you'll get x raised to power minus 1 by 2 minus 1 is minus 3 by 2. So that's the differentiation. And if you want to simplify, you can, but the differentiation is done. If we talk about only the differentiation is done. But if you want to simplify, we can write this 1 over 2 x raised to power positive 1 by 2. We can write here x raised to power positive 3 by 2. We can write, and further we can write 1 over 2 under root x and minus 1 over under root x cube. Gee, I hope this is clear. That was the first rule of differentiation. Okay, now second rule, if there is a whole power. But before that, I can tell you that suppose you don't know that rule. If you have to differentiate this 3x minus 1 whole power 2. If you want to differentiate this d by dx 3x minus 1 whole power 2. So what we have to do, first we need to open the square. If you open the square, it will be 9x square minus 6x plus 1. A minus b whole square is a square minus 2ab plus b square. Now, once you have opened the square, now you can differentiate this. And now if you differentiate, you will get 18x minus 6. Okay, now if two functions are getting multiplication, if you want to differentiate 3x with 5x. Okay, 3x and 5x is getting multiplication and you want to differentiate. This is, okay, man, I'm going to change this a bit. This is say 3x square into 5x. Now the mistake usually people make here is they differentiate 3x square separately, they differentiate 5x separately and then multiply them. Remember, we can't do that. If there's a sum or difference, like here, this was being added with this one and subtracted, so you can differentiate all of them separately. But if they are multiplying, you cannot do that कि आप first को differentiate करें, multiply by second को differentiate करें. So what we have to do here, we have to first multiply inside and then we will differentiate. Like we will write d by dx of 3 times 5 is 15 x cube. Now we have multiplied them. Now we can differentiate them, and after differentiation we will get 45 x square. There is no rule कि आप multiply हो रहे हैं तो उनको अलग अलग differentiate कर दें. There is no such rule. Addition and subtraction के लिए there is. You can, if they are being added or subtracted, you will differentiate them separately, individually. But this is not possible for multiplication and for division. If we have another example of this, like if 5x minus 7 is getting multiplication with 2x plus 3. So how will you differentiate this? We cannot differentiate 5x minus separately and 2x plus 3 separately because they are multiplying. So there is no rule that in multiplication, differentiation acts separately. So what we have to do, we don't have to differentiate in this step. First, we will multiply them. Okay, if you multiply them, you will get 5x into 2x, 10x squared. 5x into 3x is 15x minus 14x minus 21. We can simplify 10x squared plus 15x minus 14x is plus 1x minus 21. Now they are written in the form of sum or difference. Now we can differentiate them. So if we differentiate them, it will become 20x plus the differentiation of x is 1 and the differentiation of 21 is constant, which is 0. So we cannot differentiate separately if they are getting multiplication or division. Now, one case of division. If you want to differentiate 3x square minus 7x plus 1 with x. The wrong method is you differentiate numerator separately 6x minus 7 and the denominator separately 1. This is wrong. Okay, numerator ko if you differentiate you will get 6x minus 7 and the denominator is x, its differentiation is 1. So you cannot differentiate numerator and denominator separately. There is no such rule. You can differentiate separately if there is a sum or difference. You can differentiate each term separately, but for division and multiplication you cannot do that. So how to differentiate this one now? We know that this x is being divided with each term. We can write 3x squared by x minus 7x over x plus 1 over x. We can write like this. Now the next step is 3x squared over x will be cancelled out. You'll get 3x. Minus 7x over x is cancelled out, 7 only. And if you shift this x into the numerator, you'll get x raised to power minus 1. Now there is no division. Now you can differentiate each one of them separately. So the differentiation of 3x will be 3. The differentiation of minus 7 is simply minus 0. And the differentiation of x raised to power minus 1 is minus x raised to power minus 1 is minus 2. So we got 3 minus 1 over x square. Right? Okay, one question for you. You have to differentiate. Okay, on the next page, you have to differentiate x square minus x plus 3 under root x over under root x. Differentiate this now. Okay, we need to write x square over under root x. Under root x is basically x power 1 by 2 minus x over under root x mean power 1 by 2 plus 3 under root x over under root x. We need to recall indices O level D3 chapter number 2. If the bases are same, in division powers will be subtracted. I'm not differentiating them. I'm writing d by dx as it is. So x squared divided by x raised to power 1 by 2. Bases are same, so powers will be subtracted. 2 minus 1 by 2 is 3 by 2 minus x power 1, 1 minus 1 by 2, x power 1 by 2. This and this will be cancelled, so 3. Now you can differentiate them. So if we differentiate this, you will get 3 by 2 coefficient x raised to power 3 by 2 minus 1 is 1 by 2. 1 by 2 coefficient x raised to power 1 by 2 minus 1 is minus 1 by 2. And the derivative of 3 is 0. So you can write your answer like that, 3 over 2 under root x minus 1 over 2. If you bring x raised to power minus 1 by 2 into the denominator, it will become plus 1 by 2 and you can write that under root x. G, is that clear? Any question? So we did some practice by using that first rule. Now the second rule is, here we wrote the first rule. Now the second rule, if there is a whole power, like we know x raised to power n, we know how to differentiate it, will become n will become coefficient and you'll subtract 1 from the power. So it will become n x raised to power n minus 1. Now the second rule is, if you want to differentiate an expression of this form, ax plus b whole power n, if there is a whole power, how to differentiate? Now that's the second rule we are going to study. The differentiation of that type of expression is, we will again write that power n as a coefficient. Ax plus b base will be written as it is, ax plus b as it is, whole power, subtract 1 from the power n minus 1. It looks similar. The power will become coefficient and subtract 1 from the power. But one additional thing here is that you have to multiply with the derivative of inner, differentiation of inner. What is inner mean? Base. If it is ax plus b, what's the differentiation of ax plus b? Okay, what's the differentiation of 7x plus 3? The differentiation of 7x plus 3 is 7. The differentiation of ax plus b is a. So I said k, once you have written n as a coefficient and one you have subtracted 1 from the power, then you have to further multiply with the derivative of the base, derivative of the inner, which is a. So you can write a n a x plus b whole power n minus 1. You can simply write like this. Now what does it mean? Let's do the examples, then you will see कि क्या हो रहा है. If we have to differentiate 3x minus 2 whole power 7, if you want to differentiate this 3x minus 2 whole power 7, it's quite difficult to open this whole power 7. We know the binomial theorem, but it will be difficult, very difficult to open by using binomial theorem first. That is a long method itself, and then differentiate. So that's a direct method that without opening the bracket, without opening by using binomial theorem, directly we can do that. Bring that 7 power in as a coefficient. Base 3x minus 2 as it is, no change. And subtract 1 from the power, 6. And further, we have to multiply with the derivative of inner, and inner ka derivative is 3. 3x minus 2 ke differentiation is 3. So finally, we'll get 7 times 3 we'll get 21 into 3x minus 2 whole power 6. If we have to differentiate 5 minus 4x whole power 8, 5 minus 4x whole power 8, 8 will become coefficient. 5 minus 4x as it is, subtract 1 from the power, it will become 7. And what's the inner? Inner is 5 minus 4x. What's the derivative of 5 minus 4x? 5 ki differentiation is 0, and the differentiation of minus 4x is minus 4. Remember, not positive 4. So into minus 4. Yes, you are right. So you will get 8 into minus 4. You can write like minus 32 into 5 minus 4x whole power 7. If you have to differentiate x square minus 3x plus 2 whole power 20. So let's differentiate. 20 power will become coefficient, x square minus 3x plus 2 whole power. 20 minus 1 is 19. into the derivative of inner, the differentiation of inner, the differentiation of base. And what's the differentiation of base? The base is x squared minus 3x plus 2. So its differentiation is 2x minus 3. If you have to differentiate this, 3x minus 2 whole power minus 3. Rule is same. So it will become minus 3, 3x minus 2 whole power minus 3 minus 1 is minus 4 into the derivative of inner is 3. So you will get minus 9 into 3x minus 2 whole power minus 4. Okay, let's take a fraction. If we have to differentiate like 5x minus 1 whole power 3 by 5. So the same rule, 3 by 5 will become coefficient, 5x minus 1 whole power. So what is 3 by 5 minus 1? 3 by 5 minus 1 is minus 2 by 3, minus 2 by 5 into the derivative of inner, which is 5. Now if you multiply 3 by 5 with 5, 5 and 5 will be cancelled out, so you'll get only 3. And you can shift 5x minus 1 into the denominator to make the power positive. Okay, now if you have to differentiate this, now this is a question for you. 3 over under root 5x minus 4. Differentiate this. Okay, Smile, I'm going to the previous page. You have to differentiate it yourself. Yes, if we differentiate this, we will get d by dx. So you have to keep writing d by dx if you are not differentiating. You need to write this 3 over 5x minus 4 whole power 1 by 2. Now first, we need to shift this whole into the numerator. So this will be d by dx 3 as it is. I'm not differentiating in this step. If I bring this into the numerator, it will become minus 1 by 2. Now we are ready to differentiate this. So 3 is the coefficient, remember, this will stay as it is. And minus 1 by 2 will become the coefficient. So 3 into minus 1 by 2 is minus 3 by 2 into 5x minus 4 whole power. So if you subtract 1 from minus 1 by 2, so minus 1 by 2 minus 1 is minus 3 by 2 into, you don't forget to write the derivative of inner, the derivative of base, which is 5 into 5. So we got 5 into minus 3 is minus 15 by 2. And to make the power positive, we can shift that into the numerator. We'll get 5x minus 4 whole power positive 3 by 2. Gee, am I clear? So Ismail was asking for the previous page. Here it is. G, any question? So today we have learned the two basic rules of the differentiation. Now, if you know these two rules of differentiation, now we can do more questions by tomorrow in which we will be using the actual use of this differentiation, that how will you will use this in finding the gradient. Yes, Mikhail?
सर ये आप इस पेज का जो पहला वाला पार्ट है उसमें 2x-3 कैसे आया वो मुझे समझ नहीं आ रहा.
Into the derivative of inner होता है. तो what's the differentiation of x square, Mikhail? Okay, now I think you got it. The differentiation of x square is 2x and the differentiation of minus 3x is minus 3. So always in the product, we have to write the derivative of inner. Okay, that is it from today. See you tomorrow. Thank you so much. Allah Hafiz.